Hi. Today we are going to talk about what the users get out of observability. Before we start, let me introduce myself. I am Jose Carlos Chavez. I work as a software engineer at Expedia, but I am also a core team member at Zipkin. Zipkin is a distributed tracing platform, as you might know. So what I usually like to do when I talk about something is first to ask what is the problem we are trying to solve. And in this case, we are talking about observability. So what is the problem we are trying to solve with observability? Well, observability emerged from the need of the users willing to untangle the complexity coming from more distributed and independent software components and their interactions. Interactions are quite important in terms of distributed systems, mostly because they are unpredictable and because they are dynamic, right? The way I like to illustrate this problem is the well-known three-bodied problem, where we have three bodies and they are moving based on the gravity force, right? And then the problem to be solved is to determine at a certain point in time how they are moving and where they are, right? Unfortunately, although this problem is very old, and there is no way to solve this problem analytically, mostly because interactions are very chaotic, right? And we cannot exactly determine where this body is going to be at this point of the time and at what speed is going to move. The same with distributed systems. We cannot just predict how this is going to behave in this request, right? Because there are a lot of dependencies and you don't know how they are or how they interact together. So what we try to understand with observability is interactions and correlations, also operational deviations, also failure modes, and also critical components or paths, right? Which are basically, if I do this request, what are the components involved? But how do we get to understand that? Well, it's well known that knowledge is power, because understanding the system starts by collecting signals, basically, to build our models and aggregates and use them to understand the interactions in our systems, right? So in the need of data, usually users look for tooling, right? To collect data and signals, mainly about the system, signals that the system emits. So what usually users look for? Well, it actually depends on the level of the user in the field of observability and also the scale, but also it depends on the use case, right? Beginners usually look for instrumentation. Instrumentation is basically the kind of libraries that, while in your code, they collect signals of the operation of your system, right? It can collect metrics, traces, logs. And beginners usually look for instrumentation for different languages and models. It can be client-server, it can be messaging, right? They also look for working examples because it's a new concept that they are trying out. So a working example that describes what is happening and how is quite helpful. And the third thing is the right sampling rate, because you cannot afford collecting every single piece of data because that's going to be expensive and that's going to impact your storage. So usually the first question is, okay, what is the sampling rate I'm going to use? Is it going to be 5%? Is it going to be 10%? It can be 30%, depending on your storage. There's actually not a good number. It actually depends on your circumstance. Then intermediate users now know more about these concerns, and then usually they are looking for more data. They are usually looking for more granular data. It's not enough to know that service A calls service B, but okay, which parameter service A sent to service B, right? What were the scopes of the authentication, right? What was the token? What was the plan of the user, right? These kind of things are what you're looking for to give a better or to get a better understanding on why a request ended up in an error or a latency or whatever. They usually also look for correlation across observability tools, right? Because saying that you're gonna improve your operational experience with distributed tracing is a partial truth. You also need the other friends, right? You need logs, you need metrics, you need alerts, you need any kind, you need proofs, uh, complementary information, because they focus on different stuff, right? Um, they also look for dependency graphs because they want to see what are the components involved in a request, how the components interact together. That's good to know because nobody has it in mind, because although you can be the service that receives the request, there can be downstream lots of services you don't know, and that you just know that you call an endpoint, right? And this is also important when you, for example, have to set your SLOs, right? You cannot just define them by yourself. You need to understand your dependencies, SLOs. This is just an example. You cannot blindly say, okay, I'm going to provide this SLO because my service is very good, right? And then they also look for the right sampling strategy, because a fixed sample rate for all requests is not enough. It's not good enough anymore, right? Probably you want to take another strategy. You want to use the reservoir strategy, where you collect 100 traces in a minute. Or you want to have this rate, but variable rate, right? So different sampling strategies. And then there is these advanced users that usually are more knowledgeable in terms of what observability is, what are the tools, and need to get more information out of the normal data that is collected, right? And even though they realize that they don't know what they don't know, right? The famous unknown unknowns. So they usually look for post-facto processing and aggregation, because they cannot beforehand set what they are going to need. And then they probably want to need a big chunk and then analyze and process it. And in that analyze and process, understand, okay, this is going to be useful, this is not, right? They're looking for proactive feedback, because the more they know, the more they realize they don't know, right? So pretending that you are gonna understand the full system in your head is probably not a good idea. Then you need the system to be proactive and telling you, okay, this is gonna happen, this is failing, or this is gonna fail at this point, right? You need the observability tools to be more proactive. And then more configurable sampling, right? Because now you realize that you should sample case by case. Probably in the payment endpoint, you want to sample 100%, or for regular users, you want to sample 10%, but for premium users, you want to sample 30%, right? Because they are more of your interest due to the nature of their plan. So as you can see, some of them have and require more shallow knowledge and understanding about the problem, but some of them require a more deep one. But what do users really want, right? Because what I described are mostly tools and features that are imposed by the aggregate, right? When we talk aggregates, we talk about traces, which are a sort of aggregate, or metrics, but in the end, they all are aggregates of events that happen in your system, right? So they usually end up asking for features of imposed aggregates, but in the end, what they look for is that they just want that failing request to be traced, that log field with the malformed data to be included, that deviating metric to be emitted, right? Or that alert to be configured in the deviating metric, whatever they need when they need it, right? Because in the end, they are looking for certainty, right? They cannot know beforehand what they are going to need, but they want to be able to have it when they need it, right? Unfortunately, we cannot have that in all cases, right? Recording 100% of the data is not an option for every single company because it's going to be a huge amount of money in terms of retention and storage, and in scale concerns, right? Also, you need, if you need high cardinality because you want to get to the granularity of metrics for a single user, because this is the unique user that is failing for this request, well, that's going to be also expensive, and it will be not useful in many cases, right? So it's a massive effort, and probably the benefit is not as good as you think. Also, 100% availability is not a realistic goal and probably not a healthy goal, right? Because you don't want to understand every single error in your platform, or at least if you want to understand that, you don't want to tackle every single error in your platform, because if an error is not affecting a user, then why would you care, right? I remember someone telling me, an outage is basically when the user can say that there was an outage or a problem, right? If the user cannot say that because they did not perceive it, why would you expend money on fixing it or on investigating it, right? Maybe, for example, you have a failing endpoint and then you have a retry mechanism that fixes the problem. And it's okay because although the requests are longer, maybe it's an endpoint that is not being called too frequently, right? And transitioning from a reactive to a proactive model in terms of data processing is still work in progress, right? There are, of course, initiatives that do this, but they are very focused and very specific to use cases, right? So that is still something that arose with observability, but they're still growing up. So what we like to think about is that users actually need solutions that help them to understand the problems and the boundaries, right? We of course think that if we could have something to fix the problems by itself, right, and we just plug it into the system and everything is gonna be solved, that will be great. But as of now, we need to understand the problems and the boundaries, right? In that sense, I want to talk briefly about Zipkin, because that's mainly the aim of Zipkin, right? Zipkin is a distributed tracing solution based on Big Brother BERT, at Twitter. That was a platform on Twitter and inspired by Google Dapper. It was open sourced in 2012. It has a mature tracing model that emerged basically from user needs. You can tell that because most of the features are discussed by users. It's been used by large companies like Netflix, Line, SoundCloud, Yelp, but it's also used in small companies or medium companies. And it has a strong and very heterogeneous community. Like not two committers are coming from the same company, because we have committers all around the companies, and they come from heterogeneous background with different use cases, and that's what enrich this community. So what can Zipkin do for you? Well, Zipkin can do 4 things, and well, it can do more, but like these 4 things, it can do it really good. It can help you to understand the request latency sources, right? In requests or in messaging. It can identify or help you to identify critical path in a request that traverses many components, right? Like in a distributed environment. You can get an overview of your system or your services dependencies. As I said, it's useful when you want to provide an objective of availability, or when you want to understand what are your weak points when it comes to serving traffic, right? And it also helps you to pinpoint which service is at fault when an error occurs, right? Which is important because, as I said, downstream dependencies can be different, and you might not know that a service that is failing even existed, right, before you saw the error. So knowing what service is at fault and who to page is really useful. Well, Zipkin has this wonderful UI which tells you how a transaction went in the distributed trace, basically telling you which or telling you what were the components involved, which one took what, which one took this time, and which one were like the slowest ones, which was the one which failed, right? All this information you can get from a distributed trace. Because traces are usually request scoped, so you focus on one single request, and then you can see all the participants in that request. It can also show you this dependency graph that can help you to understand your topology in terms of how your components are being distributed, how they contact to each other, what are the ones receiving more traffic, and what are the ones that are doing more requests, right? What can Zipkin offer you in terms of observability, right? In terms of what is needed for observability? Well, Zipkin provides a very advanced instrumentation for various framework and libraries, only more than 26 in Java, but we have different languages. We have Go, we have PHP, we have JavaScript or Node. It also provides various exporters to different storages, meaning that you can send Zipkin data to different sources or different storages, not only to Zipkin. It has a comprehensive UI with many features, right, that you can take advantage of, that basically were poor by users. Actually, or UI was designed or developed by a user, which is Line, right? But it had a lot of feedback from other users at Yelp or Netflix. And most of the features came from that. We have at Zipkin, we have a very strong culture about knowledge spreading. We write rational documents, side docs for everything. Every discussion is documented, and we extensively discuss it with users. And we have a very supporting community over GitHub, Gitter, and Stack Overflow. What are the popular Zipkin features? Well, we have a very strong data model that has been poured over the years, that is well known and widely used for different tracing libraries, not only Zipkin. We have a de facto standard propagation format, which is B3, which is used by most of tracers and have been there for a while. We have integration with other observability tools for both server and instrumentation, like, for example, loggers and metrics ingestion, even for dispatching data to a secondary storage that is not Zipkin. And we have a versatile API in terms of instrumentation that embrace interoperability with other tracing libraries that, for example, AWS X-Ray or Haystack or Open Tracing. Right, and we have also experimental Zipkin features, mostly driven by users. For example, Yelp developed this Firehose mode where you don't have sampling or you don't care about sampling, because sampled spans go to one source and unsampled spans go to another source for further processing, right? Because sometimes the point of or the actual key point of a failure is in an unsampled trace by chance, We have secondary sampler, which basically can trigger a sampling decision at any point when it's convenient, right? This is when you need advanced sampling techniques, right? When you want to control how deep you sample, because you don't want to end up in a trace with thousands of levels, but you want to focus on what is important. There is this Kafka storage aggregation, which does post-facto sampling, like basically you decide the sampling after the trace is finished, which makes sense because then you can choose those that are that has more latency or that has the error. And that's ipso facto aggregations, meaning that aggregations are being done when the traces are coming. We have a storage forwarder, which works for multi-storage. As I said, those are features that are developed by users, and that makes the Zipkin community so unique. So what is next for Zipkin? Well, we are working on to enable propagated fields, basically being able or make users able to decide what fields to propagate, right? In a more like in a solid API. More flexible configuration, because more and more users want to decide how to configure the storages for Zipkin, for example. A good abstraction for messaging instrumentation, which is a work in progress now, and more instrumentation for popular languages or frameworks. Right, that is what coming up for Zipkin. And as a bonus, I want to mention Haystack. Haystack is an observability platform developed by the Expedia Group. Apart from the UI that they develop, which is very nice, they develop some other advanced tools for analysis and processing of data. By the way, Haystack is using or is moving towards using Zipkin instrumentation, but then all the post-processing of the data, they are doing, or we are doing really good stuff. Like I'm part of Expedia, but I'm not working exactly in Haystack. We have Haystack Trends, which helps you to find trends among spans data, like success rate, error rate, right? And find trends out of that data. We have adaptive alerting, which is an anomalies detector that helps to detect issues faster, right? To reduce the time to respond to incidents in production, right? That's what the kind of proactive observability tooling I was talking about. They have blobs, which is a request response recorder. Basically helps you to inspect the request and response in a distributed trace, for example. And then Pitchfork, which ingest and dispatch Zipkin data into Haystack and Zipkin, right? Which is quite cool. So conclusions, I'm out of time. Observability is a mean, not a goal, right? It's a mean for improving the operational experience and for help in outages. Different users have different scales and different needs. Either way, you need to know their needs, because it's important what users need to design the features, not necessarily theoretically design features. Data collection is still foundational for observability, right? That's why you should choose wisely the instrumentation. And analysis and processing of data is becoming more and more important because we want more proactive feedback from observability, right? This section is for you to read more about some concept of observability. Thank you. Thanks for having me here.